Hi guys, so it is our math time, and today we are going to be talking about multiplication again, but it's going to be a little bit different. We're going to have one more day of drawing models, and then we're going to go into straight learning algorithms, and we'll talk about what algorithms mean. Today we're going to learn about commutative properties, and this is going to show us that numbers can be multiplied in any order, and the product will be the same. Okay, so it doesn't matter which order you put the numbers, you're still going to get the same product. A product is the answer. So let's kind of look at this multiplication. So 6 times 7, these are called factors. So the numbers that we're multiplying, guys, are called factors. We're going to start using this vocabulary when we multiply. So 6 times 7 are our factors, and that equals 42, which is our product. Okay, so we are multiplying factors to get our product. So 6 times 7 equals 42. I can still get the same product if I multiply 7 times 6 equals 42. So if you notice, the products are the same, but my factors are in a different order. Okay, so once again, the numbers that we multiply are called factors, and they equal a product. Okay, so say that with me. Factors are what we multiply to equal our product. Okay, so we have factors and products. So we're going to go to the Elmo, and we are going to start working on the page that says order. I think it says order doesn't matter, or something like that. It's the one with the frogs. Okay, so get out that handout. It actually says Wednesday on it, and we are going to start that one. Hey guys, so we talked about the commutative property, so that is what we're going to work on. So you need a handout that says order does order matter? That was the name of the worksheet, okay? And so we have two scenarios that we're going to read. So let's figure out how these are related to commutative property. So frog hops 4 times each time he hops 5 feet. How far does frog hop? So he has 4 times and he goes 5 feet every time he jumps. So let's do my number line. Okay, so here's the first jump, that's 5. Jump 2, that's 10, 15, and 20. So he jumps 20 feet. Now let's show that in an array. So that would be 4 groups, because each one of these is a group. So 1, 2, 3, 4. Okay, so that'd be 4 groups of 5 because we're counting by 5. So that would be 4 rows of 5. So 1, 2, 3, 4, 5. That's 1, 2, 3, 4. Okay, and remember guys, at any time you can stop during the video to pause. Okay, now let's do equal groups. Remember, each hop is a group, so I have 4 groups, 1, 2, 3, 4. And we are counting by 5, so each group needs to have 5. Okay, so our equation would be 4 times 5 equals 20. Okay, so remember, these two numbers are our factors, and this number is our product. Okay, so we need to start using factors and products. Okay, so this is the model for this problem. Let's see the model for this problem. Toad hops 5 times each time he hops 4 feet. So my number line, and I'm going to hop 5 times. So 1, that's 4, 8, 12, 16, 20. Now if you notice, we both get 20. The only difference is I'm counting by 5s, and over here I'm counting by 4s, okay? So even though the number lines are different, we still get the same product. Okay, so let's do our arrays. So this is actually going to be 5 groups of 4. So I'm going to do 5 rows of 4. 1, 2, 3, 4, 5. And that gives me 20. Now I'm going to draw my 5 groups of 4. Okay. So this still equals 20 because I have 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. My equation, though, is going to be 5 times 4 equals 20. So my factors are 5 and 4. And my product is 20. Okay, so let's kind of look at these two problems. How are they the same? How are they the same? I want you to think about that for a minute. How is this problem the same as this one? So I want you to look at the equation and look at the problems. Okay, if you said that the factors and products are the same, you are correct. The factors and products are the same. Okay, now I want you to think about what is different about both of them. I want you to look at the models. How are they different? If you said that the models look different from each other, you're right. Okay, so remember, guys, this is what we call commutative. I'll write it up here. We call this commutative property. And that is where you have the same numbers that can be multiplied in any order. So numbers can be multiplied in any order and the product will be the same. So 4 times 5 equals 20 and 5 times 4 equals 20. They're the same numbers, they're in different orders. The only thing that is different is the models that you draw for them. So the factors and the products stay the same, but the models look different. All right, guys, on the back, you have one to do. So I want you to read the scenarios. Draw the number line, the array, the equal groups, and the equation. Remember, your equation is going to be blank times blank equals blank. Okay? So you need your factor times your factor equals your product. And then answer the question, who has more plants in her garden? What did the two solutions have in common? Situations have in common. So what did they have in common? All right, guys.